Math! Hey everybody, this is Mr. Regener and this is the Aftermath. Today we are focused on focus for week number 9. So today I'll be going over our 9.2 activity, or our week 9 day 2 activity. Feel free to follow along at home as you watch our video, and we'll get started with number 1. Number 1 says, the table shows the annual salary for 4 jobs. There's a copywriter who makes $56,359 a year, a librarian who makes $50,403 a year, an elevator technician who makes $77,200 a year, and an aircraft mechanic who makes $52,675 a year. Based on the information, how much more will an elevator technician make than a librarian over 10 years? And we have some multiple choice options. So in order to solve this problem, there's a couple ways we could do it. One way is to multiply each of those salaries by 10 to figure out their salary over the course of 10 years and then subtract to find the difference. Or we could actually subtract to find the difference first and then multiply that difference by 10 because that'll be the difference over 10 years. What I'm going to choose to do today is to multiply first and then subtract. Again, either way works, either way will find your answer. Let's go to the paper and get to work. So on this one, we have a couple of distractors in here because we only need to know about the elevator technician and the librarian. The aircraft mechanic and the copywriter are just extra information. So the librarian makes $50,403 per year for the librarian. And then our elevator technician makes $77,200. So the ET, we'll call him, $77,200. Now if I multiply any number by 10, there's a shortcut, and that is just to move our decimal place over to the right one space. We've done that a lot for our metric conversions, and the same thing applies here. If I do that, I'm basically just adding in a 0 at the end. And so that would be my 10-year salary. I'd have to move my comma over one space to make that make a little more sense. So the librarian's making $504,030 a year, or for 10 years, and the elevator technician makes $772,000 over 10 years. So to find the difference then, I subtract $772,504.30, and I'll subtract. So 0 minus 0 gives me 0. I need to do some borrowing here. That becomes a 1. This becomes a 10 that turns into a 9. And then that becomes a 10. 10 minus 3 is 7. 9 minus 0 is 9. I'm going to add my comma in there just for fun to make sure I have the placeholder in there that I need. 1 minus 4, I'm going to have to borrow. This becomes a 6. That 11 is now there. 11 minus 4, that gives me 7. 6 minus 0 is 6. 7 minus 5 is 2. So as I look at my multiple choice options, $267,970 would be the difference, and that answer today is answer choice B. Let's move on and take a look at number 2. Now in number 2, this is a question about aquariums, and we have a lot of words. There's just a ton of words, ton of numbers in number 2. We want to make sure we read the problem very, very carefully and try to piece apart what the problem is telling us. And as we've been practicing all week, a visual may be the most helpful thing for us so we can actually see what the problem is saying. Let's take a look at it right now. Number 2 says, there are 2 tanks at an aquarium, tank A and tank B. Each tank has 2 sections. The volume of one section of tank A is 29 cubic feet. The volume of the other section of tank A is 98 cubic feet. Tank B has the same volume as tank A. The volume of one section of tank B is 57 cubic feet. What is the volume in cubic feet of the other section of tank B? So for this, again, visuals are going to be key. Let me get to my paper here and I'll show you what I mean. So here I am on my paper. Just kind of divide that. And I'm going to go ahead and draw a very simple version of a tank. Now obviously these tanks would be in 3 dimensions, but I'm just going to make them rectangles. Why? Because that's what I feel like doing. Now each of them are split up. There's a divider in each of them, and we know that each of them are the same amount of volume. So I'm going to put that equal sign in there. So I'm just going to piece apart some information right from the story problem. So first it says that one section of tank A is going to be 29 cubic feet. So I'll just call that section 29 cubic feet. I know another section is 98 cubic feet. There's 98 cubic feet. If I can figure out the total volume of cubic feet for tank A, I know that's going to be equal to the total volume in cubic feet for tank B because they're the same. So I can do some quick math here and figure out that total. That would be 98 for the first part, 29 for the second part, and I'm just adding them together. So 9 plus 8, 9 plus 2 plus 1 is 12. That means this is 127 cubic feet, which also means this is 127 cubic feet for tank B. So I know the total. The problem also tells me that one section of tank B is 57 cubic feet. Got to throw my label in there. So the unknown would be this other section of tank B. So I know the total, I know part of it, and I want to know the unknown part. So I can do this by simply subtracting, because my total minus the known part is going to tell me the unknown part. So I'll set up my subtraction problem, 127 minus 57. When I subtract 7 minus 7 is 0. 2 minus 5, I'm going to have to borrow, which I can do, which that basically just becomes 12 anyway. So 12 minus 5 is going to give me 7. So my unknown part right here is going to be 70, and I have to throw my label in there somehow, so it's 70 cubic feet. Really important to have that label in there and to make sure our answer is clear. So as I review this one, we had to figure out the total volume of tank A based on the information they gave us for the volume of the two parts. From there, I knew the volume total for tank B, and I knew 1/2 of the tank based on what they told me. I had to figure out the unknown part by doing a simple subtraction problem. And so there you have our work for number 2. I feel like number 2 is potentially the toughest one in our focus this week, but it's nothing we can't handle by just making sense of the word problem. Let's move on to number 3. Number 3 says, you buy a shirt for $8.59 and a hat for $7.54. You give the cashier a $20 bill. How much change do you receive? All right, so this is a pretty typical real life type problem that we might come across in our daily lives. We're buying things, we're paying with money, and whenever you're buying things and paying with cash, you always want to double check and make sure you're getting the change back that you should. So that's exactly what this problem is doing. So let's go to our paper and get to work. First up, we want to make sure that we know the total for our shirt and our hat. So I know the shirt costs $8.59 and the hat costs $7.54. I can easily figure out the total then by adding them together. So 9 plus 4 gives me 13, 5 plus 5 is 10, plus 1 is 11, and now I have 8 plus 7 plus 1, that's 16. I drop my decimal down just straight through the floor like a bowling ball, so my total then is $16.13. Some people might be tempted to stop right there, but we have to read the whole problem and realize that we're paying with a $20 bill. Now watch what I do with $20. I write it with my decimal point and the 00 here for cents, because I have to line up my decimals whenever I'm subtracting. And that's exactly what I'm going to be doing. I'm going to take my $20, take away the amount that I paid total for the shirt and the hat, and that's going to tell me how much change I get back, or what the difference would be. So this problem doesn't seem that scary, but there's a whole bunch of borrowing going on, and you want to make sure that you're borrowing correctly and writing things accurately so you're not going to make silly mistakes. So I can't take 0 minus 3. I have to borrow from the 0, which I have to borrow from that 0, which I have to borrow from that 2. the 2 becomes a 1. Technically that 0 becomes a 10, which then becomes a 9. This 0 becomes a 10, but that becomes a 9. And now finally this 0 can become a 10. So 10 minus 3 is 7, 9 minus 1 is 8. Drop my decimal point down like a bowling ball through the floor. 9 minus 6 is 3, and 1 minus 1 is 0. So my total here is $3.87. That's how much change I'm expected to get back. So there you have it, number 3. Again, real life scenario. We're purchasing things, we're paying with money, and we're getting our change back. Let's move on to number 4. Now for number 4, the key word here is perfect square. You're going to see it in the problem, and it's really important that we understand what a perfect square is. Perfect square is going to be the result of a number squared. So think to yourself, 2 squared. That's 2 times 2, which equals 4. 4 is a perfect square. All right, with that being said, let's take a look at our paper here and look at each individual option that we have to figure out which ones are perfect squares. I'm going to show you kind of a neat technique that you can borrow and use for yourself that's going to guarantee that you get number 4 correct on your quiz. Let's take a look at it. So the first thing that I'm going to do on my paper here is actually write out all of my perfect squares. All right, so I'm going to start with 2. So 2 squared equals 2 times 2, which equals 4. 4 is a perfect square. I'm going to just do the same thing here all along my paper. All right, so there I have all of my perfect squares nice and neat lined up here. I got a little bit tight here at the bottom of my page, so hopefully you can read all of those. And this wasn't difficult math for me to do. It's kind of basic math facts. But knowing all of these basic math facts kind of leads me through my answers for number 4. So if I look at my options, letter B says 8. Now looking at my list here, 8 would fall somewhere between 4 and 9. Somewhere between 2 squared and 3 squared. It's not a perfect square because it's not listed here as one of my perfect squares. Letter C is 49. If I just glance through here, oop, there's 49. 7 squared, or 7 times 7, equals 49. 121, check it out. Boop, there I am. It's 11 squared. 11 times 11 is 121. 121 is a perfect square. And then I have 140. I don't see it along my list here. In fact, it would be somewhere between 11 squared and 12 squared, but it's not one of those, so it's not a perfect square. Letter E would not be correct. So there you have our focus for this week. As you're preparing and studying, I hope this video is helpful for you, but don't forget to do your own work on your own paper because that's the most helpful thing for you. I'm Mr. Regener. This has been The Aftermath.
Math! Aftermath, it's the aftermath. Aftermath, it's the aftermath. Math class is fun, but when it's done, stay in the zone. On your own, it's math review, made just for you. Take a video wherever you go. Aftermath, it's the aftermath. Aftermath, it's the aftermath. Oh yeah.